And now we're back for our first episode of full wave and half wave rectification. Good times. So we looked at RMS and instantaneous voltage and things like that. So we use the term RMS when we're dealing with a sine wave, but when we're dealing here with pulsating DC, we can use the term average. So because, just to recap, the average voltage in an AC sine wave is 0 because of the equal values on each side of the positive and negative pulses. So what we're looking at here is rectification. In this circuit, this design is known as a bridge rectifier, which is how DC is sent. We generate, rectify, and then convert it back. So from the dam to the city, it gets converted into DC. So we use bridge rectifiers, and this just keeps getting more and more closer to a DC, less and less pulse. But anyway, so if we have a full wave rectifier, that means we're rectifying the full wave. But what's happening here is, with this design, these diodes are not allowing the sine wave to dip into the negative. Everything is staying positive. So you have the positive cycle right here, and this next cycle would typically be the negative cycle. But because of this configuration, everything stays positive. So we call that pulsating DC. So now we can use the term average. So what we have here is a full wave rectified voltage is 0.637 of the peak voltage. And when we dealt with RMS, everything came back to the peak, right? So RMS was peak times 0.707. Inversely, the peak would be the RMS times 1.414 or divided by 0.707. And if we go here, you'll find that this number is simply half of that. When we deal half wave rectified, we have just pulse, and then this portion is removed, and then we have another pulse and remove. So half wave rectified, full wave rectified, not too complicated as far as the concept is concerned. So if we move on down the line here, and we just play with the numbers a little bit. So we have a peak of 170 volts. The RMS is what? What is the peak to peak? What is the full wave rectified and the half wave rectified? So we've dealt with RMS and peak to peak. The RMS is the peak times 0.707, gives us 120 volts. So the peak to peak is 240 volts. And full wave rectified is the peak times 0.637, gives us 108 volts. And half wave rectified gives us 54 volts. Peak times 0.3185. So again, just change it up here. Peak is 200 volts. What's the RMS? Peak to peak, full wave and half wave rectified. Same deal. 141.4. Peak to peak, 200. Peak to peak, so 400 volts. Full wave rectified, 127.4, and half wave, which will be half, 63.7. So you want to pause the video here. Got a peak of 300 volts. What is the RMS, peak to peak, full wave, and half wave rectification? Pause now. We'll be back right now. So the RMS, 212.1, peak to peak, 600, 300 volts times 2. Full wave, 191.1, and half wave, 95.5. So if we carry on, try it again. We're going to move beyond this here, but just give it another try. Pause the video. And the answer, we have, so what I've given you here is the RMS value. So what is the peak? Peak to peak, full wave and half wave rectified. So just a little change up here. RMS 0.707 gives us 160 volts for the peak. Peak to peak, twice that. And then once we have our peak voltage, it all sort of just unfolds. Full wave 101.9, half wave 50.9. So now, for these next questions, we have to do a little bit of also a couple extra steps to get to the answer. So RMS, this is not too bad here. So the peak, so pause the video after this. So you got peak to peak, 180. What's the full wave? If the full wave is 76.4, what's the peak to peak? Half wave. Full wave rectified, what's the RMS? And half wave, what's the RMS? So pause the video, see if you can work those out. And the answer is, or the answers are, 80 volts for the peak, full wave rectified, 57.3, peak to peak, 240 volts, half wave, 60 volts for the peak, RMS 81.3, and for the half wave, the RMS being 49.4. So again, nothing too complicated as far as concept is concerned. Just have to understand what's going on within these calculations here, how to get in and out. So we're just operating in some of these questions in reverse. So for example, I give you the half wave rectified. If this is already halfway rectified, well, we take the ratio of 63.7 to 0.3185, so we basically would have 63.7, and again, this number has to go up to hit for the peak, right? The peak is going to be the higher value. So when you multiply by a decimal, the number goes down. When you divide by a decimal, the number goes up. So since the peak is the number that's a higher value, well, we're going to take the ratio, and again, we're just working backwards here. And then once you're at the peak, everything else just falls into place. It's always about getting back to that peak value and understanding that. So if I give you half wave rectified, you're looking at the ratio of 63.7 to 0.3185, or 63.7 divided by 0.3185. Same here. We just go backwards, 127.4, the ratio of 127.4 to 0.637, or 127.4 divided by 0.637, gives us the peak. And again, once we hit the peak, everything sort of just falls into place. So it's really just as simple as that. Just have to understand those relationships, and you should be good to go. That is it for rectification.